He kōna e purangi tēnei nā te reo irirangi o Aotearoa.
It's interesting because I have a new trainee and she came to me talking about it recently, being like the level of anxiety of knowing at any point on shift you get thrown into response. It is something you carry with you. We also carry it with us off shift, because we have a high level of camaraderie in this team. We all support each other, which means you're also aware of your friends going through it. I've found after 5 years it's certainly more manageable now, but the first few years it was very apparent that you're sort of existing with this low level of anxiety due to the nature of being a type of first responder.
Kia ora, nau mai haru mai ki te au hurihanga. Hello and welcome to Our Changing World, ko klekin canon tēnei. That was the voice of Kimberly Priso, a shift leader in the National Geohazard Monitoring Centre.
I've been a geohazard analyst for 5 years and I run a team of 4 GHAs round the clock, 24/7.
That's right. Te puna mōrearea I te ru, the National Geohazard Monitoring Centre, or NGMC for short, never closes. It's a large clear glass windowed room with a meeting space next to it that Kimberly and I are chatting in, but more importantly, just outside is the kitchen space, stocked with essentials.
5 types of coffee, yeah, very important. We also have a wellness room, so there's a place for people to go if we are doing fatigue management. Of course, doing night shifts and having 4 people on shift, we do have the ability to support each other if people are like beyond tired or if there's some issue or if they have to leave. We have better benefits than a lot of people, I think, with sick leave. This is due to the fact that inevitably shift workers will also face more sickness just because of fatigue. So we're very well supported by GeoNet and GNS as well to do our job and to be in that permanent state of readiness for that event that could happen on any given day.
The shifts are 6 a.m. to 2 p.m, 2 p.m. to 10 p.m, and 10 p.m. to 6 a.m. And the GHAs, the geohazard analysts, are on alert for anything unusual popping up on the monitors during that time. And when I say monitors, I mean the massive bank of giant screens that pepper one whole wall of the large space. You know in movies when you see spacecraft launch centres or command rooms where there are just monitors everywhere? That's what you should picture. But instead of troop positions or rocket launches, there are live feeds from cameras near volcanoes, maps of the Pacific with little flashing triangles, and a whole lot of squiggly lines. Information coming in from the seismometers around the Motu.
So you can see the volcanoes on the top left there. The majority of the screens are showing incoming seismic signals or incoming seismic noise from the sensors. The second screen you can see there shows the last earthquake that happened, which was a 1.7 near Taupo. Below that we have fault reports and we have strong motion products. We have international stations as well, and we have tide gauges and our DART buoys, which are our deep sea tsunami tool. You become sort of after the first year, I think, quite good at pattern recognition, and you'll find yourself constantly looking and seeing if anything's changed on those screens. And it's actually quite remarkable how fast, I guess, you can notice something that's changed or going wrong.
And that's the job of the NGMC, to keep an eye out for geohazards, for things going wrong. It's part of GeoNet, New Zealand's Geohazard Monitoring and Response organisation.
GeoNet collects a vast array of data monitoring New Zealand's 4 main geohazard perils, which are earthquakes, tsunamis, landslides, and volcanoes.
This is Dr. Jonathan Hansen, the GeoNet data manager and an on-call duty seismologist and a member of the Volcano Monitoring Group. These 4 hazards can be interconnected, and earthquakes are kind of the bread and butter of monitoring.
Earthquakes are kind of the core of monitoring almost all 4 of those. So we get earthquakes when there's movement of magma at a volcano. And then also we get earthquakes that can cause tsunamis and landslides. So earthquakes are kind of interesting. So earthquakes, when we think of them typically, we're talking about movement along a fault. And well, that movement can be tens of meters or more and along faults that are hundreds of kilometers or more at their biggest extents. That actual fault movement doesn't pose too much of an impact to humans unless you're literally on, say, a place where that fault hits the surface. The big impacts from earthquakes are shaking and potentially tsunamis if they're generated. So if you have a big displacement of the seafloor, that will displace the water above it, which is what generates a tsunami from an earthquake. And then the shaking, it can be really, really strong from an earthquake, and that's what causes a lot of the damage to buildings, or it can cause what we call kind of cascading hazards, which is when shaking can cause things like landslides.
We'll get back to Jonathan later for more about his on-call duty seismologist role. But first back to Kimberley and the National Geohazard Monitoring Centre. The NGMC is based at GNS in Lower Hutt in Wellington and opened in this 24/7 format in December 2018. It's coming up on its 5th birthday now. Now, I know I said imagine a rocket launch or command centre, but in movies they can be a bit hectic, with people in headsets waving paper and shouting things frantically. The NGMC is a bit more chill. Well, it is at the moment anyway.
We try to avoid too many alarms due to the concept of alarm fatigue. We do have an alarm or a pager goes off for greater than magnitude 6 onshore New Zealand, or nearshore, onshore, nearshore. Beyond that, we have pager alarms for international agencies as well, such as the Pacific Tsunami Warning Centre. And beyond that, to be honest, a lot of it is us locating based on what we see on those screens. We have a lot of data incoming, so it is apparent when an earthquake happens or if something unusual is happening.
So the pager is for greater than 6 magnitude earthquakes. But of course there are smaller earthquakes happening all the time.
The expectation is that we will get 20 earthquakes at least per shift. That can go up and down. It can go up a lot if we have a swarm. We've had up to 120 earthquakes on a shift before. So I think what you're describing is that 98% of the time we're in a state of business as usual. But for that 2% of time, there's an element of readiness because we will have to respond rapidly to something significant. Something that we do to help that is that we cannot be more than 45 seconds from the bridge. So the cafeteria is about the extent. I have definitely been on shift when we've had to hoon back through the hallways, probably scare some staff, to get back to the bridge in order to help a colleague because we always leave one person on the bridge, so at all times. Can't leave it unmanned, which means we have a bunch of failovers and a bunch of other ways that we can, resilience, I suppose, to make sure that all of our data is continuous.
Yeah, they call it the bridge, like on a ship. We've been looking in through the glass windows, and while the full bank of monitors is on the wall straight ahead, there's one monitor hanging on the right-hand side, just counting the number of earthquakes that have been located since the centre first went live in 2018. And it's up to over 107,000 earthquakes.
It's really interesting looking at the counter. Obviously, several thousand earthquakes are associated with each person. And also, there's a lot of other interesting events in there, such as quarry blasts and explosions from Waiouru or offshore events. So, there's a lot of nuance behind that number, that it's not just onshore events.
Is that any earthquake or over a certain size?
Certainly over a certain size. You need 10 stations to be going off or to be receiving a signal within a similar time frame in order for the software to then alert us automatically to an earthquake, and then we'll proceed to look at that automatic solution and correct or change if required. Some events, very small events, won't be picked up by the system, but are occasionally also picked up by GHAs.
And is it the GHAs who will also assess things that the sensors are kind of pinging as an earthquake that may not necessarily have been?
Yeah, for sure. Occasionally you can even get just a really noisy day or a lot of noise on the sensors that can behave. The system wants to be like, this is an earthquake, and it may not be so. So that's why we have people there double checking and making sure it makes sense. Or in the instance that we might have 2 events happen, one in the North Island and one in the South Island, and together the system might actually try to say that that's one event, in which case the GHA goes in and separates those events into 2 distinct earthquakes.
Can we head in?
Sure, of course.
Can we go onto the bridge? Captain?
Let's interrupt. Like a pirate. What we need is an earthquake to happen, so you can watch one real time.
And so if one were to happen, where am I going to be able to see that?
So initially, if you're very good at spotting something, you might spot a series of triangles flashing in a group, red or changing colour.
So every one of those little triangles on that map of New Zealand is a seismic sensor?
That's right, yeah. And then you can see some offshore that are very helpful for picking offshore earthquakes. And then you can see international stations also.
So there's like a map that's basically the Pacific Ring of Fire with more triangles.
That are flashing, yeah. So in the event that it triggers, we'll see this screen, so a screen that basically gives the details of the event. Initially, there won't be a magnitude because it hasn't been calculated yet. Initially, there'll be a preliminary depth and a preliminary location, and that's what we'll go in and we'll double check everything makes sense, and then add stations usually to reinforce that the solution is correct, and then commit that as the best review. That's just what you see on GeoNet.
So there'll be an sensor will pick it up, a seismic sensor will pick it up and ping it, and then somebody in here will actually look at it, and across the time, 5 or 10 minutes that it takes, you'll line up other sensors, you'll figure out a more accurate magnitude for it and location, and then that gets updated again.
That's right. And so, yeah, within the centre, there's a wide variety of experience, but we're all generally either of a background of geology, geography, or emergency disaster risk. So that means that we also have a very strong base knowledge of New Zealand geology. So there's also a little bit of, does this earthquake make sense for this location? Is this accurate? And so that we can then use that to go in and check the sensors and make sure that it's accurate. So what you see first is an automatic solution that changes to a preliminary solution very quickly, so within 3 to 5 minutes, and then that will quickly change to a best, which is considered a confirmed solution.
That's why then things on the GeoNet app, let's say, might change slightly after the original kind of ping of an earthquake magnitude.
That's
it might
right.
then get updated and changed later on.
Yes, the software might decide something. Like I said before, there may be 2 events, there may be a little bit of confusion with noise, there may be an event coming in from offshore, which means the software, it might say there's an event in Gisborne, for example, but it's actually offshore. So then we go in, we'll check, and then we'll move it to its correct location, and then we will start checking the magnitude. So what you see first will always, more data will be added, and it will become a better solution as time goes on. The subsequent magnitudes are always better than the initial one.
So the 3 other GHAs are quietly monitoring things right now. But what happens if there is a reasonably sized earthquake?
We have a very clear escalation pathway. So we're right now in condition green. So that means green light go. We can have tours, we can do project work. I can see Ryan doing admin. Condition blue is considered enhanced monitoring, and that's where our first step as far as if we see something unusual or we can see something coming in from offshore. We'll go to condition blue to assess. Within minutes, we'll have an idea of whether to escalate to condition orange. Orange is when we would then bring in people like Jono, our duty staff, in to assist, or even the operations manager, or even more GHAs on occasion. From there, we're usually in comms with civil defence, and we can either escalate to condition red if it's a very serious scenario, or condition purple, which means failover, which means actually something's gone wrong, a network's gone wrong or gone down, or some sort of issue like that.
Jono here is Dr. Jonathan Hansen. So when things go to orange in the NGMC, if he's on duty, he'll be getting that call.
As a duty seismologist, I'm kind of a early responder to earthquake and tsunamis. So you've already visited the NGMC, you've seen what we're doing on the 24/7 and analyst side there. And that's just the start of the scientific response to a geohazard at GeoNet and at GNS. So basically, the analysts, if there's an event that meets a few different thresholds or potentially has caused damage or there's the potential for a tsunami, they will page me, and then I will be there as quickly as I can to join the response.
So when you are working as an on-duty seismologist, you've got the pager on you at all times.
At all times.
And if something happens, you're straight away answering that page. I mean, are you looking at the data? Like, what's the next step on your side?
Yeah, so that's exactly what the next step is on my side, starting to look at the data, maybe helping to refine some of the outputs that are coming out of the NGMC. And also I'll start engaging with civil defense in a different way, maybe providing a bit more expertise about what they might be facing, or just potentially providing a wider lens. And then I'm only the first escalation for a big response. So then we activate expert panels. So I mentioned I was in the volcano monitoring group. That's the expert group that gets activated for a volcano. But we also have a tsunami experts panel and an earthquake experts panel too. So GNS and the whole country starts to spin up this big scientific response. And at the big end of things, think a Kaikoura, something like that, pretty much all of GNS is responding, as well as colleagues around the country.
Though sometimes he doesn't even need to be paged.
I was on call on March 5th, 2021, when we had 3 tsunami threats to New Zealand in one day.
Well, the early morning got off to a hell of a shaky start and there was no respite, with thousands of coast dwellers sent scrambling for the hills.
And that day started at about 2:30 in the morning, when there was a magnitude 7.3 earthquake off the East Cape. And the shaking from that event will have arrived at our seismometers about 10 to 15 seconds later, and obviously been quite widely felt by people in the region, in the East Cape. That shaking traveled down to Wellington about a minute later, and then that's what actually woke me up. So even before I got paged, I was lying in bed and I got woken up by the earthquake. And at that point, I'm acting just like anybody else. So the first thing I'm trying to do is do my kind of internal assessment of the shaking, thinking about long or strong, get gone. So if the earthquake shaking is strong enough that I think I would have difficulty standing up in it, or if the shaking lasts about a minute or more, then the best thing you can do is to self-evacuate if you live in a tsunami-prone zone, like I do in Lyle Bay. So those were the first thoughts that went through my head. Then I realized that I probably didn't need to evacuate myself and my whānau today. So I pulled on pajamas, I got myself a glass of water, pulled out my laptop and settled in for what I knew would be a significant period of response.
And so his workday begins at the bright and early time of 2:30 a.m.
The first thing I did is I would have joined a conference call with the NGMC and talked to the analysts who had already been responding for, by that point, let's say 5 to 10 minutes. So they already had a preliminary location of the event. They were already assessing its tsunami potential and talking to civil defense about that. So the first thing I would have done is basically kind of confirmed that what they were seeing kind of lines up with my kind of judgment or opinion about this event too, and just make sure that we were pushing the right advice to civil defense as quickly as possible. But one thing that really stood out to me from that day is, so we did advise civil defense to issue a tsunami warning for the East Cape and the top of the North Island. But even before we issued that warning, the people on the East Cape had done perfectly. So by and large, there'd been a lot of self-evacuation based on long or strong, get gone. And so when the warning came out, people were already moving, and that's perfect.
But the day got a little bit more complicated, right?
Yeah, you could say that. So later on in the day, at about 7:30 a.m.
Yeah, most of us are just waking up then, but Jonathan has already been working for 5 hours.
We had another earthquake, and that was followed shortly by an even bigger earthquake, both of these two up in the Kermadex near Rowell Island. They were about a 7.3 and an 8.1, so these are big events. And they both posed a tsunami threat to New Zealand, and especially the 8.1. So our day kind of rolled on from there. And we have seismometers on Rowell Island, and we also have coastal tsunami gauges at Rowell Island. So we use those to kind of get a preliminary earthquake source. We also use international stations up there. And then our DART network really came to play, especially around the 8.1 event.
Deployed in 2019 and 2020, the New Zealand Deep Ocean Assessment and Reporting on Tsunami Network is a collection of 12 sensors spread across the southwestern Pacific Ocean, with a focus on the Hikurangi, Kermadec, Tongan and Vanuatu trenches. Each one has an ocean bottom pressure sensor, which sits on the seafloor and records the pressure of the water column above it, and a surface buoy, which transmits that data via satellite back to GNS. When nothing is happening, the DART sensors send a packet of data from sea to land every 6 hours, with observations at 15-minute intervals. But when a tsunami wave travels over the bottom pressure sensor, the change of pressure triggers event mode, and it starts sending data packages with 15-second intervals. The DART sensors can also be triggered manually from the NGMC.
We can use the earthquake source to estimate a tsunami that has been generated, but these tsunami meters actually measure that tsunami. So they give us another level of information to build our advice upon. So that let us know that there was definitely a tsunami had been generated by these events and that it was going to impact New Zealand.
Kei te rū te whenua. A massive evacuation effort is underway throughout the north of the country following an 8.1 earthquake off the Kermadec Islands at 8:30 this morning. It has triggered tsunami waves expected to reach New Zealand's coast shortly, although it is not known how big they will be.
This one day with 3 different earthquakes sets up a kind of tsunami risk compare and contrast. The magnitude 7.3 East Cape earthquake was large, close, and strongly felt across the country. Because it wasn't far off the coast, any tsunami would arrive quickly. But, as Jonathan said, many people in the East Cape were woken by it and immediately self-evacuated. The later 7.4 and 8.1 earthquakes in the Kermadecs were larger, but further away, meaning people probably didn't feel them, so no self-evacuation was going to happen.
It might have been lightly felt, but definitely not enough for people to have been self-evacuating. So a tsunami from that region takes about an hour to an hour and a half to arrive. So there is a bit of time for us to push the warning through civil defense. But one of the things that's really tricky about tsunamis is that the first arrivals are not necessarily the biggest. And in fact, the biggest waves or impacts related to that tsunami could be several hours later. So you have to keep quite a long watching brief around tsunami. And again, that's where our DART network can be really useful, because not only can it confirm when there is a tsunami coming, but it can also help us understand when that threat has started to pass. So that let us on March 5th give an all clear kind of signal to NEMA or Civil Defense, which they passed on to the public, of course, probably about 4 to 8 hours earlier than we would have normally been able to have done. And that's because previously we'd have to wait for the tsunami to arrive at our coast. So we have to see it on our coastal tsunami gauges to be fully confident about the tsunamis that are being generated out there.
When you've evacuated from your house at like 9 a.m. in the morning with a screaming toddler, I suspect that knowing it's safe to go back 4 to 8 hours earlier is very helpful indeed. And luckily on March the 5th, in the end, when the waves came to mainland Aotearoa, they weren't very large.
We started to observe a 30-centimetre tsunami arriving from that East Cape event. And then later in the day, we had these much bigger Kermadec events. Those triggered a kind of more national warning. And so they activated the National Crisis Management Centre at the Beehive. And myself and a few other colleagues from GNS actually went to the Beehive to provide kind of scientific advice to the response in person. So I was there until about 2:30 in the afternoon when we finally started to call off and wrap up the tsunami response side of that. And by then we'd observed a tsunami of about, I think it was 40 centimetres arriving at Great Barrier Island, and much, much larger ones arriving at Rao itself. In a nutshell, those tsunamis represented what we call beach and marine threats. And the real impact that day would have been some pretty spectacular videos and photos. And anybody who might have been at the coast at the time could have been impacted. So it's still the right call to back away from the land and evacuate. But we were quite lucky in that none of those tsunamis eventuated in a really big arrival at New Zealand.
The role of the NGMC is a very practical one: to use different sensors and tools to monitor hazards, to inform civil defence, to minimise risk to human life. But there's also a huge amount of data that's being collected by GeoNet, and every event, like this triple earthquake and tsunami risk day, is a chance to learn more.
The data that is collected at GeoNet and elsewhere feeds into studies on faults or the likelihood of different shaking responses in different locations. And that research, which is really fundamental stuff, and there are entire projects focused on that, then feeds back into response so that we get this kind of virtuous circle of data to research back to tools, which generally produces more data, and we go back around again.
We started this episode talking to Kimberly Priso about anxiety in the work as a geohazard analyst. That constant hum of knowing that at any moment you might be responding to a big event, something that means real consequences. I wondered if it was the same for Jonathan. When you're on duty and the pager goes off, what does that feel like?
Well, my heart definitely leaps up into my mouth. And my first thought is always for my own and my family's safety. And it's after that I start to engage scientifically. Like many people, especially around Christchurch, you start to become your own seismometer. And you can start to judge duration of shaking and intensity of shaking. And already I'm starting to think about where the likely earthquake is behind that and whether it might come with a tsunami source or something like that. So my brain has already leapt into a kind of active state. And so by the time if I felt the shaking, I'm usually responding before I get the page. If not, by the time I sit down and start to see that information, I'm just really starting to grapple with what are the impacts of this event? Not just what happened, but what does this mean for New Zealand? What does this mean for civil defence? How are we going to be responding from this? As well as, do I need more colleagues to help me with this?
And, you know, I mean, I asked you the question about being an on-duty seismologist, but with the job that you do and the knowledge that you have, are you ever really off-duty if you feel an earthquake shake?
The short answer is no. So I would respond to any significant event basically as soon as I knew about it. And the other thing to remember is there's a team of on-duty seismologists. And in a big event, we will activate a lot of us. And we will start to be dividing up the role. So somebody might be doing some more comms, like radio interviews, like this one. While one person will be staying really close to civil defense and the scientific advice. And we'll also be thinking about how we're going to stagger ourselves, because responses can last quite a long time. So we talked about March 5th, 2021 lasting about 12 hours. The Hunga Tonga Hunga Hapai eruption lasted for weeks in a kind of response state for us at GNS. So relatively quickly, you're also starting to think about how you're going to keep this going, who you need to be active in different roles, and yeah, preparing for the long haul.
Thanks to Kimberly Priso and Dr. Jonathan Hansen of GeoNet and GNS. This one was produced by me, Claire Kincannon, with help from Liz Garton and Ellen Rikers. Sound engineering was by Steve Burridge, and Tim Watkin is executive producer of podcasts and series at RNZ. Our webpage is at rnz.co.nz/ourchangingworld. And if you've got feedback for us, you can email ourchangingworld@rnz.co.nz or find us on social media on Facebook or X, where we are at RNZ Science. Tēnā koe I whakarongo mai. Thanks so much for listening. Ko Claire Kincannon ahau. Have a great week. Kia pai te wiki.